My name is Andrew. As mentioned previously, I've been working at JetBrains for several years. Previously, I have worked on the app source project. I have noticed that some of you were reviewing some code on your laptops, and the people are using GitHub, and it is awful. So please use app source. It's way better for code reviewing. But then I fell in love with Scala and moved to the Scala plugin team, and here I am. Here are some of my credentials, my email, Twitter handle, the same as GitHub handle, so you can contact me directly if you feel like that. So at the Scala Days Copenhagen, I had suffered of some weird technical issues, so I decided to make my slides in the most JetBrains way with IntelliJ IDEA. So let's give it a try. Okay. To the next slide. Okay. The question I'm trying to ask is, what's your everyday IDE? Yeah, it's just to warm up. Who's using IntelliJ? Okay, nice. Okay, Eclipse. Okay, NetBeans. None of us. Enzyme, maybe. Okay, yeah. Sublime. I guess some of you. Okay, yeah. And my role models, VI or Emacs. Yeah, okay. The next question is about more about Lightband interactive platform. So does anyone use it? I mean, it's not necessary to use it in its own entirety, but not only Akka. Who does use it? Okay. Only Akka. Okay. And I don't use reactive platform. Okay, yeah. Moving forward. So before I'll show you some code, yeah, there's going to be a live coding session. So before I will show you some code, what I'm going to do. Today I'm going to show you some latest features of IntelliJ that are related to Akka. We have recently added them to make your programming life easier, to make you do okay. Never mind. Yes, to make you spend less time debugging, try and figure out why the hell is happening and stuff like that. So, and what are we going to do today? We are going to create a very simple game, something like table tennis game, and during that I will show you some new features. Okay, let's create a player. Obviously, it's going to be an actor, class, player, extends, actor. Yeah. We're going to implement the receive function, the most simple receive function. Okay, now we need to create an actor system. Let's create an actor system. Actor system, and with some stupid name, named actor system. Now we're going to extract it, and here we go. The first Akka-inspired feature is that. So we can defined named system. The name suggestion based on the named parameter. Yeah, the first parameter is called name, so we can determine that it's something meaningful. So we can use it as a name for our variable. Now we are going to create props object. Props, okay. Let's import it. Class of player. Okay. And then, oops. And then we're going to create an actor reference. Actor of props, and with a name, okay, player, for instance, and create a reference player. Okay, but let's assume that we have decided to add a constructor parameter for our player, something like name of type string. And what's the problem? If we run our code now, there would be a runtime error. I hope everybody knows that. So there is a first inspection that appropriate actor constructor not found because there is no constructor with 0 arguments. So we need to add an argument of type string. I don't know, parameter. Okay, and now there would be no error. Also, there would be error if we change the expression. Now there is an expression of type integer, and there is no appropriate constructor. Let's try to define another constructor of type int. Oops, I don't know, name of type int, this name to string. And the marker disappeared. Okay. Another feature is something like that. We can create a companion object, and I guess it's sometimes it's very painful to write the code like that. Props plus of blah blah blah. So people are used to define vector methods inside the companion object. So now a method called props with parameter of type string and stuff like that. So now there is no need to do it explicitly. You can generate an actor factory method. Moreover, there are 2 factory methods generated, one with a parameter of type integer and the other one with the parameter of type string. Okay, have a look on the right side of the expression of the method. Here it's safe to call the constructor directly because we are inside of the companion object and there is no closure. So there is no need to create props in this way. So it's simpler and it's faster. But now there is yet another inspection that such a call could be replaced with a factor method call. We have just generated 2 of them, and we can replace it. Yeah, something like that. Okay, there is. Let's roll it back. We can delete our functions, and there is an intention. We can create corresponding factor methods in such a way, and the actual call would be replaced with the call of factor method. So yet another feature is new find usages types. Let's consider we have a message, a regular case class called message with a parameter msg of type string. Everybody is used to develop something like this, message with simple parameter match case message, I don't know, empty string and the default branch. Okay, so now let's try to find all the usages of the type message. There are two of them. One is an extractor here, because there is it's a syntax sugar of the unapply method, and there is another find usage for method apply. Here it's been created a message by the apply call. But let's try to write something like that inside the receive function. We can pattern match MSG, and another branch is going to be list of messages and placeholder. Okay, now let's try to find all the usages again. There would be another one type. It's called receiver position, and it means that there is an actor who could receive such kind of messages. Yeah, because there is a branch that receives a message. But still, there is another one, extractor, because that means that they not an object of type list is actually received. So let's add. Let's see what happened next. We can resend our message. We are going to resend our message. We're going to sender ask, but the problem is that ask pattern is not imported. Everybody needs to write something like this: import Akka pattern ask, but it's painful. Nowadays you can run the not basic but magic completion, and it's going to be imported. Yeah, you can see it. Ask and pass a new message to our sender msg plus msg, and let's compile it. Obviously it's not going to be compiled since there is no implicit parameter timeout. So okay, let's define it. Let's define it like that. Timeout. Okay, 3.sec and magic completion seconds, extracting variable and defining it implicit. Okay, let's do it once again. Okay, now everything compiles. Let's see what happened. There is yet another find usages type. It's called ask position, and that means that somewhere the place exists where case class message has been an object of type message has been sent somewhere to some sender, for instance. Okay, we can write something like that, exclamation mark and message, dummy message, and run find usages again. The same ask position, extractor, method apply, but there is a send position here. Yeah, that means that it's been sent with an exclamation mark. The other ways to send are tell, forward, and stuff like that. Okay, forward, and pass a message, and it should be also determined as a send position. Yeah, like that. So same rules apply for ask pattern. You can write it in the infix form with a question mark, message, msg, and find usages, run again. Ask position here twice. Okay. And one of the most powerful features of the latest release is not related to Akka very tight as the features I have mentioned. It is very useful for debugging. For debugging asynchronous applications. So let's open another file. It's called table tennis, and that's basically the same thing I have written recently. So there are two players, one player and the second one, and they hit the ball one to another. So there is a case class ball, and it counts the number of how many times it's been hit. Okay, if we try to debug it, let's set a breakpoint here and here. There are first player and second player are obviously the same, but I have put them separately to show that debugging actually switches the player. So now we are going to debug it. Okay. Compiling. Just wait a second. Okay, and here we go. And there is a regular stack trace of a asynchronous application. You may see that ping switches with the pong string. So, but there are frames. The stack trace is hardball, and it's not very simple to figure out a bug if there is such a bug. So let's do a strange thing. Oh, we can go to the setting, to the preferences, to the build execution deployment, and then async stack traces. Oh, I'm sorry. I need to switch presentation mode off. Okay. Yeah. I had previously downloaded them on my laptop, so I'll show you how to do it. Never mind. But there are two XMLs, one for Akka features. One is for Scala concurrent features and one is for Akka actors. And we had enabled something which is going to make our life happier. And we can put a tick here, capture local variables, on the bottom. May greatly slow down the execution. Okay, clicking OK and starting debugging once again. Let's see what happens. Yeah. The stack trace looks completely different. We can debug through our application, and we see that stack traces are glued one to each other. So here we are in second player, and here we are in the first player, and moreover, we know the actual values of some variables. There is a variable named count in hitball message, so here it is 4, 3, let's debug, okay, 11, and stuff like that. So, okay, thanks. Yeah, it's very handy and useful, I guess, for most of the people. Yeah, there are some gurus that know how to cook it properly without debugging, but how much people could do that? So, to the XMLs. Oh, Jesus. Okay, interesting. Yeah, fine. The problem of the feature is that it's not the final state of the feature, so it's going to be rewritten somehow to adapt it for all the libraries, but there is a GitHub repository. I can write it like that because I cannot show you. So it's capture points. Yeah, and there are several XMLs defined in the project. In that project, so one of them is for Akka, one of them is for Scala concurrent, one of them is for Java concurrent library. There are settings for Swing library and stuff like that. So you can download some of that XMLs and simply, and simply enable capture points here. So there are for Scala concurrent and for Akka actors. So that's the main idea of the capture points. Later it's going to be rewritten, as I mentioned, so it would be more useful. And you are not going to be supposed to download something from somewhere. Yeah, it's not very good. So, okay, back to the presentation mode. Yeah. And to the slides. Okay. What are we going to do next? There is a list of simplified list of features that we are going to implement in the nearest release. It's message sender determination. It's very tricky, but we're going to implement it somehow. We're going to support Akka type. I bet you have I bet you know something about it. So, and we're going to implement some additional inspections, for instance, closing of mutable values to avoid it. The next slide is something like that. It's a slide from Konrad's presentation. Yeah, he did it in Copenhagen, so I decided to basically steal the slide. I hope Konrad didn't mind. So that's our U-track screenshot. So you can write a story about your Akka issue or Scala and Akka issue or plugin, Scala plugin issue, and we're going to implement it somehow. So let's do it with your help. And now to the Scala plugin roadmap in more general way. So we had recently started working on Akka on Akka framework. We are working on the Scala meta. I guess some of you had tried to use it in our plugin. We are constantly trying to increase our SBT support. For instance, there is an SBT shell in some way now. We are going to release a standalone distribution of IntelliJ with the Scala plugin built in, with the Scala SDK built in, so the regular Scala developer is going to just hit one button to download it onto one's computer. We are going to extend our .t support, and our .t support makes us to refactor and adapt our plugin to support any kind of Scala-like language. So there is a joke about Scala language with K, a German dialect. Yes, John had presented in on the 1st April, but there is an internal joke in JetBrains that since it's mostly the Russian company, we're going to support a Russian dialect of Scala named Scala in Cyrillic. So let's see what happens. Okay, and that's basically all that I wanted to mention today. So now, do you have any questions?
Time to satisfy your JetBrains curiosity. Who's up for some questions?
Oh.
Yeah, thank you very much. Very nice to see all those new features. I was wondering, how do you detect that case class, a message, is being used in, I'm here.
Oh, yeah.
Is being used on receive position? Is that just because it's used in a partial function, because that's what it is at the end? So I'm wondering if you defined just a partial function somewhere inside your actor, and later you use it in a become, if it will be detected as a receive position. Actually, that's my question, and how it's done exactly.
Yeah, that's a very good question. Yeah, nowadays it's only supported for receive function, no function that could replace a receive function somehow, but it's one of our points to determine such stuff on the compilation time. Obviously, we cannot handle all the cases because you can do some magic with the reflection, so we cannot handle it. But some days we're going to implement the full feature. Okay.
Hey, so follow up to his question there. I'm curious if, because we have type alias in actor that's receive, it's just an alias to partial function any unit. And do you in your AST, do you actually see that actor.receive type alias, or don't you have access in AST land to that thing? I was thinking if it would help if people were to annotate, okay, this partial function, that's actually the actor receive, if that would help you detect, oh yeah, that's a receive thing.
Okay, I understand the question. Thank you, Conrad, for your question. No, I mean, yes, obviously we cannot determine the return type, but it's not very. We don't use the information that it's type alias named receive, so you can replace it with the obvious partial function to unit, and that's going to work. You can eliminate the type annotation, so you can make compiler make it, but it's still the receive function, so things like that. Okay.
It actually doesn't need a crutch. Right. Awesome. Anyone else?
Okay.
Okay.
Okay. Thanks.
Whoa.
Okay.
Is it there?
Yes, last one. Scala.js support, please.
Excuse me?
Oh,
Scala.js?
support.
Yeah, okay. I hadn't heard.
So basically, he replaced you for a U-track
Okay.
issue board. So I think that's it.
Yeah, I have an answer.
Okay.
Well, actually, we have somehow Scala.js support. It's already been implemented. There are some resolution-related features, so you can try to use it. But it already exists. Yeah. Okay. What I forgot to mention is that most of those features are included in the Scala in the IntelliJ Ultimate edition because it's a global politics that frameworks are supported in the Ultimate one, and the async stack trace feature is nowadays it could be used in the regular community edition, so feel free to use it because it's not related to any particular framework itself.
So the conclusion is that now we have something except twirl support is going to spearhead the ultimate version.
Yeah.
Awesome.
And Scala.js is also included only in
the ultimate version.
Yeah.
Anyone else? We have like a minute more. Okay, actually it took like less time, so there's time for questions. Anyone else?
Okay.
Okay, let's close the talk.